Welcome back to my channel. I'm a PhD candidate specializing in statistical modeling, environmental informatics, and spatial analyses. In the last video, we talked a little bit about how kriging sometimes can outperform complex models in species distribution modeling. So today, we are going to step back and we're going to look at the two major frameworks we often use in SDM. The reality is, though, it really rarely is about the technical bells and whistles. Rather, I think modeling selection, it is actually about which one is more aligned with your research questions and goals. So, the most common approach is the correlative approach. Think machine learning, linear models. Here, the caveat is that we have to assume a static relationship between environment and species response. Basically, we are assuming if we know where a species is currently, we can predict where they will be in the future, provided the conditions are the same. But we know in reality that is rarely the case. Then we have the mechanistic approach, which it doesn't just look at where a species is, it asks why the species can be where they are. So it looks at the actual processes that structure communities. Think about dispersal limitations, biotic interactions, or physiological limitations. To see this in action, let's look at these maps for Acadian flycatcher. This is a bird species that captures insects mid-air. On the right, we have a random forest model. This is the correlative machine learning approach. And on the left, we have a HMSC, which is a Bayesian framework that incorporates traits reflecting species' ability to actually interact with the environment. Notice the differences in the probability gradients. Because HMSC reflects a species' biological mechanism, it actually has a slightly higher probability in the northwest part of the map, comparing to random forest, and lower probability in the southwest part near those major cities where you see those three darker or bluer spots, clusters. And those are the major cities. So this is actually capturing the impact of urbanization, and which a purely mathematical model might smooth over. Well, now you might be asking, which one should I use? The answer is, it depends on your goal. If you want to know why species is responding to change, perhaps for a long-term conservation plan, then HMSC or any other joint species distribution models that can allow you to incorporate more information would be a better option. Because this is showing you how species might interact with the environment based on their biological strengths and limitations. But the trade-off here, though, is that this requires large computational power. It can be pretty intense. Then random forest, on the other hand, is a cost-effective solution. It can handle large data set and it can process large-scale predictions fairly fast. So that could be your option if you don't really care about the how and why, you really just want to predict. But remember, the trade-off here is that you are actually trading biological insight for speed. So what's the major takeaway? It's actually quite simple. Use correlative approach like random forest if you want a fast, accurate map. Use mechanistic frameworks like HMSC if you want to defend the how. But I actually want to hear from you. What are you working on? Are you working on any projects right now? You are actually choosing between speed and biological depths? Or are you having any dilemmas about modeling choices? Drop your species and your modeling choice in the comments.